All right, good morning. Welcome. We're going to be working on 3 questions right now for the FRQs. We're going to focus on the BC questions for the 2019 practice exam. That's going to be question number 2, number 5, and number 6. All right, number 2. So in question number 2, we have a laser that produces a beam of light. The position of the laser is going to be represented by a vector function. Both x and y are going to be measured in centimeters. The time t is going to be measured in seconds. And we are given that the laser has an initial position at 0, 0. That means that x is 0, y is 0, at t is equal to 0. Oh, it says right there, yeah. And the design takes 3.1 seconds to complete. We're also given the differential equation for x, and we're given the derivative for y. Okay. Find the speed of the laser at 3 seconds. Well, we're going to have to know the formula for speed, and the formula is it's the square root of x prime of t squared plus y prime of t squared. All you got to do really is plug it into the calculator really carefully. Make sure you're squaring the entire quantity. Your calculator should look something like this. 3 cosine parentheses. Since we're plugging in 3, that's going to make it a 9. So 9 squared plus y prime. So 4 cosine of 2.5 times 3. If you really don't want a mistake, you can just multiply it out. 2.5 times 3 and just leave it like that. Let the calculator do the work for you. Squared. I think the biggest mistake here is going to be making sure that everything is in parentheses so that you're squaring the entire quantity and not just like a number. The answer is 3.06 centimeters per second. And that's going to be the speed of the laser. The speed of the laser at 3 seconds. This question is pretty straightforward. Again, it could be kind of simple to make a mistake on the calculator portion, but this question is only worth 1 point. Find the total distance traveled by the laser from 1 second to 3 seconds. Well, total distance is going to be the integral of speed. So that means we have the integral from 1 to 3, the square root of x prime of t squared plus y prime of t squared. Don't forget to put dt, dx, whatever we're integrating with respect to. Without that, you're not going to get the point. But here, we're going to get 1 point for setting up the integral with the correct form, your limits of integration, the variable that we're integrating with respect to, and then you're going to get 1 point for the answer, and the answer is 7.09 centimeters traveled. I'll keep it simple here, mejor. During, or I should say, from 1 second to 3 seconds. That is the second point. Oops, not two. An additional point. That's the second point for the FRQ. The laser is furthest to the right at 1.253 seconds. Find the x-coordinate of the laser's rightmost position. So they're already telling us when the laser is at its furthest to the right. But now we want to find the position. And if you want to find a position at any given time, you should probably do this general formula. F of x equals the integral from a to x of f prime of t dt plus f of a. Yes, we have an initial condition for this one. If you go back to the main paragraph, we were told that at t is equal to 0, we had the point 0, comma 0. This one's x, this one's y. So if I want to find the x coordinates position at 1.253 seconds, that means I'm going to be integrating from 0 to 1.253. 0, because that's the initial condition of x prime of t dt plus, again, the initial condition at time t is equal to 0, the x coordinate has a position of 0. And you don't even have to write the equation for x prime. You can just set it up like this. Plug it into your calculator, and we get 2.932 centimeters is the position farthest to the right. In this question, we're going to get 2 points. The first point is going to be for the integral setup, including the initial condition, and then the second point is for the answer. That already puts us at 5 points for this FRQ. And the last question, or the last part, what is the difference between the y coordinates, the y coordinate of the laser's highest position and the lowest position? So first of all, we have to find what the highest and the lowest are, and that's basically saying, find me a maximum and find me a minimum. If you think about your basic concepts, to find the maximum or a minimum, you have to find a derivative, set it equal to 0, find your critical points. Normally, we would do a number line, but because we're actually looking for the max and the min, that changes the fourth step, and we're supposed to evaluate the critical points that we find, including the endpoints, because we do have endpoints. So, step number 1. Find my derivative. We already know what my derivative is. So I'm just going to go ahead and say dy dt is equal to 0. That automatically should get you the first point. How are you going to solve this? Well, we have a calculator with us in this question, right? So graph your derivative, find your zeros, aka your x-intercepts. And when you do that, you're going to get 2 critical points within the interval. My 2 critical points are 0.628, and the other critical point is 1.885. So that covers these first 3 general steps. Now again, normally I would want to do a number line, but because we want to find the absolute maximum and the absolute minimum, I have to go and actually evaluate the critical points and the endpoints. So kind of how we worked on part C. The y coordinate at time 0, because that is one of my endpoints, right? 0 is going to be the integral from 0 to 0 of y prime of t dt plus my initial condition. Remember how in the beginning paragraph we were told that at time t is equal to 0, we have a position of 0, 0. So at 0 seconds, the y coordinate has a position of 0. And when you evaluate this, we get 0. Now the critical point, 0.628, is going to be the integral from 0 to 0.628 of y prime of t dt plus 0, and that gives us 1.6. The next critical point. Negative 1.6. The end point. And now we have 4 coordinates for the y component. Going back to the question, we want to find the difference between the y coordinate of the laser's highest position and the lowest position. So this would be the highest position. This would be the lowest. Now let's find the difference. 3. The highest minus the lowest equals 1.6 minus negative 1.6, which is 3.2 centimeters, right? Is the difference between the laser's highest position. You know what? Let's say highest and lowest position. And lowest position. Okay. So to recap this question, really we used one of our basic concepts a lot, and that was this question, right? How to evaluate, how to find a position given an initial condition. And even though we're dealing with vectors, you have to know your basics, because this basically covered half of the question. The only thing that was kind of new was knowing how to find the speed given vectors and how to find total distance traveled. All right, I'm going to stop the video right here, and I'll see you next time for question number 5.